Hello everyone. So in this video we are going to go through some general thumb rules which we should keep in mind before we start meshing. First we'll start with critical areas. So what are critical areas? The areas which is subject to high levels of stress on the geometry or structure which is under analysis are called the critical areas. So how do we capture the results in the critical areas properly? Basically by covering the critical area properly by a mesh. So as you can see here, there are two holes here. In one hole is meshed with fine elements and the other hole is meshed with coarse elements. So the this hole on the left side, which is meshed with fine elements, you can see the geometry is captured very accurately, whereas the hole on the right, here you can see the nodes are the geometry is not captured properly. The all the nodes are not coming on the edges properly, so this might not give a good result as per say, and whereas this left side geometry will give a good result, better result than the right side. So what we can derive from this is, when we have critical areas where stress levels can be high, then it's better that we mesh that area with smaller elements. So how do we mesh it with smaller elements? So for this case, I've used washer split. So you can use a washer split to separate the surface, and you can mesh that critical area around that surface with fine elements, and you can mesh the rest of the area with coarse elements. So this is one of the rules which we generally use for critical areas. We mesh the critical areas with fine elements and the rest of the areas with coarse elements. So this helps us keep the balance of elements uh, reasonable so that the analysis time doesn't go too high. Now secondly, the second thing which we can keep in mind is, whenever we have a symmetric geometry like we have here, this plate which is symmetric about the center. So what we can do here, we can mesh one part of the plate and we can just reflect or revolve or rotate that part to mesh complete the meshing of the geometry instead of meshing the whole part. So this is the second point which we can keep in mind before we start meshing. Now the third point is, when we separate the surfaces, critical areas from non-critical areas on the surface of geometry, so we should start by meshing with from the critical areas. Why is this so? Because when we start meshing from non-critical areas, what happens? The nodes on this outer periphery, for example, the nodes on the outer periphery of this circle, they will get fixed according to the coarse mesh which we have used in the non-critical areas. So while meshing in the critical areas, a mesh might not come as good as this, and there might be some irregular mesh lines in this area which might not be good for the results. So this is the third point to keep in mind, that we should start meshing from critical areas and then move on to non-critical areas. Now we'll go to the fourth point. For that I'll start with a separate geometry. So here we have a geometry. So as you can see here in this geometry, we have small fillets here. So what we generally do while meshing, if the fillets are very small, we try to remove them so that we don't have to use very small elements to mesh this geometry. The use of very small elements can lead to the increase in the unnecessary number of elements. So as you can see, when we mesh the geometry with larger elements, the fillet area doesn't get captured properly. So these elements which are in the fillet areas, if you check them, they will fail in certain quality checks. Like as you can see, these elements around the fillet area are failing in aspect ratio. So it might happen that while solving in the solver, this might not solve. So then what we have to do? Then we might have to mesh this local area as I showed before, the example of the plate. We have to mesh this area with smaller elements. But what will happen with this? This will increase the number of elements in our total number of elements in our model. So what we can do to avoid this? So for this, what we can do is we can remove this non-essential fillets. So we'll get something like this. So this can be done using the defeature option which we have here in geometry. So we can remove them, and then this is the mesh we can easily get. So as you can see here, we don't need those small elements to capture the fillet area because there are no fillets here. So the fourth point to keep in mind is we can use defeature to remove unnecessary small fillets, which might increase the number of elements we use in our geometry. So these are some of the points or thumb rules which you can keep in mind before you start meshing.